Okay, well, great. So welcome back to school, everybody, and get logged in with our multi-factor authentication. So I guess all the students are going to have to use multi-factor authentication, and I think that's a great thing. All right, I know some students gripe about this, but you should use multi-factor authentication for all of your accounts if it's available, okay? Especially your email. If your email is not using multi-factor authentication, you're running a great risky thing, okay? So whatever email you have, like any major email company will offer multi-factor authentication. Definitely you should use it because if somebody gains access to your email, then they have access to like your whole life, okay? Because all they have to do is just go into your email, search for account. They can find what websites you have an account, and they just go to that website and they say, I forgot my password, and they're gonna send a password reset to your email, and now they have access to that account, whatever it is. So you need to protect your email inbox. You need to have multi-factor authentication. Anyway, and I'm not like paid by the school to do that. I'm paid by the school, but they're not like telling me to promote this stuff. But I think it's good for UCLA to have multi-factor authentication. I know you guys are like students and you don't feel like anybody's going to hack into your account, but they could. If they gain access to your account, then suddenly they have access to all of the library subscriptions, and that opens a huge liability to the university, because as it is right now, you can go to any of these publishers, many of these publishers, and access their textbooks for free. And if an unauthorized user gets into the university system, accesses all of these libraries, and decides to just download everything, torrent them, and then spread them across the internet, the publishers will be very angry with UCLA. So they do need to protect their things. You might not feel like you do anything crazy important, but your account and VPN account gives you a lot of access, a lot of leverage on university resources. So it should be protected. And I know it's inconvenient. I know like you might have forgotten your phone somewhere or something. I posted a document last quarter with instructions on getting backup codes. I'll post that again this quarter. But I think it's good, right? Nobody complains that they need their keys to start their car. Even though we've probably all experienced a time of great stress when we couldn't find our keys and we were in a hurry. And it's not like you then said the following day, next car I'm gonna buy is not gonna have any keys because I don't wanna have to go through this process of searching for my keys again. We've accepted that you need keys to start your car. I think we should accept that we need something other than just a pure password to get into accounts, because I would say my accounts are more important, more valuable than the car I drive. So, maybe it's different for you. But okay, anyway, that's my plug on multi-factor authentication. I would say my digital accounts probably have more value than trying to think of any my physical items that I own. I don't own very much of value. So anyway, but okay. This is Stats 102C, Introduction to Monte Carlo Methods. I finally posted a syllabus, so we'll take a look at the syllabus. If you were wondering where the syllabus has been this whole time, it was nowhere. I just finished writing it this morning, and I posted it. So we'll take a look and we'll go over, I don't know, whatever it says. Okay, so I got so I'm Miles Chen. That's me. I'll be your teacher. I see a lot of familiar faces, so I'm excited. Mondays and Wednesdays, I'll have office hours at 10 o'clock and at 3 o'clock. So before this class and then after at 3 o'clock, 3 p.m. Do you guys have class at 10 a.m.? Mondays, office hours. Office hours, so we have class Monday, Wednesday, Friday. My office hours will be Monday and Wednesday, and I want to take Fridays easy. But if you want an appointment on Friday, you can send an email to me, and we'll set up an appointment for Friday. That's fine, okay? But otherwise, it'll be Mondays and Wednesdays. I got 2 hours Mondays and Wednesdays, okay? You guys know the websites. All right, we're gonna have 3 tests, 2 midterms and a final. The final will be during 10th week, okay? Because it's spring quarter, some of you guys are graduating and are, and the school sometimes schedules finals during graduation ceremonies, and I'm not okay with that because I want you guys to go to your graduation ceremony, but I don't want you to miss the final. So, we'll have the final during 10th week, okay? All right. We're using R, okay? And then for our textbooks, we'll be looking at these ones, okay? And they're all available if you on the UCLA network. So either you VPN in, or while you're connected on Wi-Fi right now, you can go to these websites and download the textbooks, okay? So free. I try to get books that are free for students. 102B, I couldn't find one that I liked, so you had to buy that one or obtain it somehow. Okay. This is what took me forever to figure out and why I didn't post it until now. Okay, the grading schemes. This is like always what is the greatest source of stress for everybody, including me. All right, and this is what I finally settled on. Okay, homework, we'll have 6 assignments, 8% each. None of them are going to be dropped, so 48% total. We'll have 3 exams. Each of them are held in class, so that means they're going to be, 45 minutes each, 50 minutes max, probably 45 minutes. So I'm willing to put like 15% of your course grade on that. I feel like otherwise, those 45 minutes are very high pressure if it's any higher than that, okay? And then we'll have class attendance 3%, Piazza participation 3%, and then that adds up to 99. So I'm going to give everybody a free point for being awesome. We will start off with the assumption that everyone's awesome. If you do something greatly not awesome, you might lose your awesome point. But you'd have to do something really bad, okay? No, I don't know. Okay. All right, here we are for homeworks. I think it's pretty straightforward. I'll post things as an R Markdown file. You'll download that. You'll fill out your answers, and then you'll render the HTML file and upload that. We can only accept HTML files. Please don't upload your R Markdown files. That's especially important for this class because in the Monte Carlo method, some of these homeworks, like you've got to run the code for like a few thousand iterations, and that takes a while to run on your computer. We don't have the luxury of like downloading someone's code and then running it for 10 minutes just to see if it runs, okay? So if you didn't run it and you just submit an RMD file, you're not gonna get credit. You need to render it as HTML, okay? And basically also, when you submit your HTML file, make sure if it asks for output, that the output is printed in the homework, okay? So this is not gonna be your homework assignment, but if it says print out the Fibonacci sequence and you write code that's valid, but you didn't produce the output, you're not going to get credit for that, okay? You have to include the line that says print out this vector, resulting vector, so that we can see what it looks like, okay? Otherwise we can't give you credit. Again, we don't have the luxury of running your code for you, especially with this Monte Carlo class, okay? All right, I've modified my late policy to be a little bit more generous, in my opinion. So generally, I'll make my homeworks due at 6 p.m. and you have a 10-minute grace period. So I will accept it to 6:10:59 according to the CCLE server. No penalty there. After that, you'll get a 5-point penalty per hour. okay, up until midnight. So at midnight, it will be a 30-point penalty. And then I will suspend the penalties until 6 p.m. the following day. So basically, if you miss the first day, you didn't get it done by midnight, you'll lose 30 points. And then you have until 6 p.m. the following day to get that in, and you'll lose just 30 points. And then if you miss 6 p.m. the following day, then the points penalties start accruing again until you're at 60 points, which is midnight the following day. And then after that, the late penalty will be maxed out at 60 points, okay? So if you submit it after that, you will have a 60-point penalty, and you will have up to 9 calendar days after that, and then you'll get a 0 for the homework. So like if you're turning in something like a week late, you'll have a 60-point late penalty, and that's how it's going to work, okay? If something happens, okay, I want to, I understand life is complicated and things get in the way, and so I want to be able to accommodate and grant extensions for homework and things like that. Usually every homework assignment, maybe 2% or 3% of students will need some kind of extension, and I want to be accommodating to that. But with so many students, even if it's only 2 to 3%, it's like that's like 5 or 6 students per homework assignment, and then if we have 6 homework assignments or something, then that ends up being 30, 40 exceptions that I have to keep track of, and it's just too much. So the way we're going to do extensions is this, okay? If you have documentation explaining why you missed the homework deadline, just submit that documentation with your homework, okay? So don't email me, right? Like you can email me, but I won't be able to keep track of it, okay? I have so many emails to try to like filter through, and I still haven't cleaned everything up. It's just too much. So when you submit your homework, submit your documentation with it, and if you submit documentation, that will give you, we'll just do 72 hours, so that gives you 3 days, okay? And that's that, okay? If you have a unusual circumstance where 72 hours is not going to be enough, then come see me, all right? Usually that means something more serious is going on that probably is not something that I feel comfortable resolving via email, and I'd rather resolve face-to-face. I'll try to be as understanding as possible, but come see me if you need more than 72 hours. So just whatever documentation it is, make sure it's got a date that says, that like makes it reasonable, that like this is why you couldn't turn the homework in on time, and then we'll do it that way. Okay, I'll make sure the settings on your homework submissions allow multiple files, and that should be fine. Okay, are there any questions on that? Does that kind of make sense? So you'll just submit the documentation right along with your homework, and that way it'll be organized for the grader to see and everything. Okay. If something happens and you miss an exam, let me know right away, and then I will give you 1 week to make up the actual exam. Okay. All right, and then this took me a long time to figure out what to do about attendance, just because it's like worth only 3 percentage points of your grade, but I had so many emails just about attendance, so students asking about their attendance. So we might take attendance. I'll take attendance on just some arbitrarily chosen days. It might be via the online tool, okay? I might do an actual roll call. I might do the online tool and then do a roll call, all right? Just to kind of make sure everyone's being honest with the online tool, because that has happened where I've taken attendance online, people who weren't in class said they were in class, and then I don't like that, okay? So I'll try to take attendance multiple times during the quarter. A lot of times I forget. So if for some reason I take attendance less than 10 times, each session will be worth at most 0.3 of a percentage point, okay? So, if I take attendance 10 times, then that 3% divided by 10 will be 0.3 of a percentage point. each. If I take it more than 10 times, then we'll do number of days present divided by number of times I took attendance. But otherwise, if I take attendance only twice, which is possible, then I'll give free points for the other 2.4 points. So, you'll get 2.4 percentage points for free, and then the attendance will count for just those remaining 0.6 of a point. Okay, I'll try to take attendance more than twice, though. And then, but this I'm going to implement, okay, which will be no excused absences will be granted, okay? So you might have a good reason for missing class, and you should definitely miss class at that time, but you're not going to get points for being in class, okay? You'll just miss out on those points, and that's fine, okay? That's how life works. You can't. Throughout your life, there's going to be different things demanding your time. You only have 24 hours. You can only be in one location at any given time, and you have to make choices. And so if there's something more important in class than class, you should go, okay? And as far as attendance points go, this ranks very, very low, all right? So if you have an interview, definitely skip class, go to the interview. That's more important, okay? You're going to just miss out on 0.3 of a point for class, and that's fine. It's not that big of a deal, right? And if, this is just another example. If your friend needs help, help your friend, okay? Your friend is more important than 0.3 of a percentage point, all right? I know, it feels like a sacrifice, but help your friend, okay? They're more important. Nobody looks back on their life and says, oh man, I wish I didn't lose 0.3 of a percentage point for attendance. Rarely do people say, like, man, I wish I spent more time working and, I don't know, being ambitious. It's usually regrets, or will be things like, I wish I invested more time in people and spent more time with the people I loved and cared about. Those, definitely, okay? 0.3 of a percentage point. It's not that big of a deal, okay? We'll have Piazza. I've got to send out invites, and I'll just have a straight Piazza participation thing. So you'll get points based on your contributions, okay? Contributions are questions asked, questions answered, comments in the follow-up discussions. Those count as contributions, okay? And then we will say the cutoffs for the 3, 2, 1 will be 12 contributions versus 7 versus 3 contributions, okay? Please don't spam the Piazza board with low-quality posts, okay? If I reserve the right to remove low-quality points, and those won't count towards your contributions if it becomes a problem. So if somebody answered the question and it was a simple question like yes, you don't need to also say yes. Okay. All right. Okay. And don't ask questions if the answer is in the syllabus either, right? Those would be considered a low quality. If you need clarification on something in the syllabus, fine. But if it's directly answered in the syllabus, that's not necessary. Okay. This is a lot of stuff that I've put on pretty much all of my syllabuses, but I'll go over it here. Okay, academic integrity. Be honest. Don't cheat. Do your own homework. Don't cheat on exams, and we won't have a problem. Okay. Gender discrimination, sexual violence, and harassment. I hope nobody goes through this, but I understand. There is an ugly side to life as well. And so, if you ever find yourself in need or a victim, the university does have resources available, and I want you guys to, feel comfortable using them. Everything you decide is ultimately your decision, but there are resources to support people, in difficult times. So we have that. Same with mental health and counseling and student well-being. School can be stressful, and so if you find your mental health suffering, please make an appointment with CAPS. I know sometimes they can be busy, and you know, so I support any efforts to continue funding CAPS and give them as much resource as they need. But you know, make an appointment, even if they say, you know, you won't be able to make an appointment until you know, a few weeks out. Go ahead, just schedule it and make use of that. Okay. If you need accommodations for any kind of disability, or you know, if something happens during the quarter, you know, this CAE is available, and so you can always talk to them and get things set up in case you need accommodations. And then okay, and then lastly, once I submit grades, those are final. But if we made some kind of mistake, you know, we can make corrections, and that you'll have up to 1 quarter to do that. And then if you have questions outside of course material, you can still come by and ask questions, and I can at least offer you my perspective regarding either grad school or working in industry and things of that nature. You know, this is just my opinion, and don't take what I have to say as like something important, but that's just, I'll happily share my experience and whatnot with you. Okay, are there any questions? Yes.
Is that okay for the attendance? Is that okay for the 9 a.m.?
No, you have to, the attendance, is especially because I'm going to use that online polling tool, all right? And that's tied to the class that you are registered in. So if you're registered in the 9 a.m. class, you have to show up at 9 a.m. to take attendance, okay? I'm not going to try to keep track of who showed up at the wrong lecture, right? It's just too much with too many students. So go to your assigned lecture and do that. If you need to make a permanent switch, then you might be able to find somebody in the lecture. So I think there are 2 students who came to me. So I don't know if there's anybody enrolled in the 11 a.m. class, this class, that wants to switch over to the 9 a.m. class, okay? And if there are, I know there's at least 2 students in the 9 a.m. class who want to switch with you and come to the 11 a.m. class. So if, I don't know, who were those students again? Oh, okay, more than 2, all right. Okay, so some students have hands raised. If you're enrolled in the 11 a.m. class and you want to switch to the 9 a.m. class for whatever reason, I would say at the end of class, you can hang out by the door and try to find somebody. I would say try to see someone. Otherwise, you have to go to your enrolled class, okay? And then if you find somebody to switch with, then what you do, the process is the 2 of you together go over to student affairs officer, either Glenda or Lori, and just say, I'm in this class and I'm in this class and we want to switch, and they can do it, okay? But both of you need to show up so they both know that it's a mutually consensual thing, that the switch is happening, okay? Otherwise we can't do it, okay? Okay, any questions? Any other questions? Course policies, whatnot? No, we're good? Okay. All right, who's graduating this, like in 10 weeks? Okay, this is awesome. All right, so I'm very excited for you guys, and I hope we enjoy this class. All right, so let's see. This is exciting. Okay, so this is 102C. The class is Monte Carlo methods. And I am going to take a little bit of instructor liberty. What is going on here? Okay, so this is lecture 2, week 1, Monday. Okay. Okay, so the class is called Monte Carlo methods. However, I'm going to take a little bit of liberty as the instructor, and I will not teach it as a strictly Monte Carlo methods class. I'm going to kind of teach it as if it were Monte Carlo methods and Bayesian statistics, okay? And that's because I believe, or I feel that Monte Carlo methods, one of its most important applications is in Bayesian statistics. Also, our undergraduate departments doesn't offer a strictly like a standalone course on Bayesian statistics anymore. So that's a little bit unfortunate. And so I want to at least expose you to some concepts and ideas in Bayesian statistics. If you took my 102B class, we covered like a very short amount of Bayesian statistics there. You'll see probably some familiar concepts again, and but we'll use it in the context of Monte Carlo methods. Okay. Okay, and then so let's talk about Monte Carlo methods. All right. So what is the Monte Carlo? Do you guys know? Huh? It's a what? Okay. It's a casino. The Monte Carlo is a casino in Monaco. And what is Monaco? Huh? It's a country, okay? Monaco is a city-state. Giving me a little bit of a... Okay, so Monaco is this tiny, tiny little country, sovereign nation that's like surrounded by France. It's like, I don't know, probably like 5 square miles. It's this tiny thing. It's like, and it's got like 20,000 people. It's probably like the size of UCLA, this little land, okay? But it's its own country, and it's surrounded by France, and their biggest industry is tourism and their casino, okay? And so anyway, this is like, you know, we think when you hear Las Vegas, you think gambling. Okay, if you're in Europe, you hear Monte Carlo, and that's like your Las Vegas. Okay, so anyway, this is all about gambling. Casino in Monaco, and you know, famous for gambling. And when we talk Monte Carlo methods, it's the idea of kind of getting probability estimates based on repetition, okay? So in gambling, you're playing the same game over and over and over again, and all of these things have been thoroughly studied, and so we have a very good idea of probabilities based on repetition, okay? Okay, so when we talk Monte Carlo methods, we are talking about ways to estimate probabilities, okay? Estimating probability based on repetition. Probabilities based on repetition. This is for gambling. And here, we're going to do it, kind of generalize it. All right. Who can give me a Stats 10 definition for the difference between theoretic probabilities versus empirical probabilities? So we'll say recall from Stats 10, right? I always laugh whenever an instructor writes recall on the in their notes, because it just means it's kind of like, if you don't remember, shame on you. But all right. Okay, so Stats 10. All right, what's the difference theoretic versus empirical probability? What do we have? So what's a theoretic probability? All right, maybe we're just shy. All right, probabilities based on what? On math. Okay. All right, probabilities based on math or mathematical rules, mathematical axioms. Just we set up the math and we do this, right? This is the focus of stats 100A, also 100B. But 100A was all focused on your theoretic probabilities. You learned about this distribution, that distribution, how they all relate. Everything's assumed to be IID, all of this stuff. Okay? All right, what's an empirical probability then? So empirical probability is what? Observed, right? So this is estimated probabilities. Okay, based on either observed repetitions or simulated trials. And if the math gets too hard to do the theoretic probabilities, then we have to resort to using empirical probabilities, right? Obviously, theoretic probabilities are nicer because we know, at least if the math is true, then, or the assumptions that we made for the math, then this should be correct, okay? And the empirical probability should be an approximation of that, right? And the law of large numbers is basically what? That the empirical probabilities will match the theoretic probabilities, right? In the long run, the empirical probabilities will match theoretic probabilities. That's the law of large numbers, okay? I'll say we'll approach theoretic. Okay, so, just a silly example. Let's say we were at the Monte Carlo, okay? So this will be a true, quote, true Monte Carlo example in that we are talking about gambling stuff. All right, so we have, let's say we're playing a game with dice. And each side should land 1/6, right? Okay, but what if you physically altered the die? So you, I don't know, used a tool and you cut off a corner or something like that, right? Oh, am I running out of battery? I don't know, okay. So we'll say cut off a corner of the die. All right, how will this affect the way the dice roll? How does this affect the dice? Okay, do we know? We don't really know, right? Well, maybe. I guess if we really understood physics and, I don't know, rotational mechanics and, I don't know, whatever. You'd have to understand physics really, really well. Maybe you could come up with some theoretic prediction of what will happen with this die where we cut off a corner, okay? But I don't know physics that well, okay? So, a theoretic answer is possible. Theoretic answer may be possible with physics, but who knows? But, this is hard. So what do we do instead? Instead, we just roll the dice, okay? We just roll the dice and see what happens. All right. That's one approach to life. Okay. And we'll keep track of the outcomes. And then if one of the sides show up more frequently or less frequently, then maybe we'll say, success. We have altered the dice, okay? And then maybe one or more sides show up more frequently or less frequently, who knows? And then we can declare our dice modification is successful in altering outcomes. So this is probably something that people did back in the 1800s or something like that, right? Like they didn't have computers to do these simulations, or their understanding of physics was probably much like ours in that they probably couldn't do the calculations, but they certainly had these dice mechanics and people messing with things, and then they would just kind of test them out and keep track and see if they successfully could alter the dice this way, right? And then, obviously if they got caught, then they were in big trouble, but who knows, right? Things are a lot more closely regulated now, and you can't easily change the dice, but you can make movies about it. All right, so today, as far as our Monte Carlo methods class, we would do something similar in that we're just avoiding the theoretic work, and we're going to do either computer simulations or random number generation or whatever it might be, okay? So I would say this, in our Monte Carlo methods class, okay, a lot of our problems can be boiled down to sampling from a probability distribution, okay? Down to sampling from an unknown or partially known, or even just a complex probability distribution. Okay. So perhaps we can do some math, maybe not all of it, but we can do some math and get an idea of what a probability distribution should look like, or some form of it, but we might not know the properties of this probability distribution, okay? So we might have some distribution that we want to learn about, some probability distribution, and maybe we want to know its know some properties like the mean. Like the mean of this distribution. And perhaps, well, how would we normally, so analytically, how would we get the mean of a distribution? So we have some, so we'll say x comes from some PDF of x, right? How do we get, how would we get the expected value, the mean of x? So analytically, the answer is what? You integrate from negative infinity to positive infinity of x times the PDF of x, right? Dx. So this is how we would do it. And this integral might be like impossible, right? Integration is hard. And so, could be really hard to do. All right, so what do? We use Monte Carlo method to estimate. Okay, so we've got concepts like Monte Carlo integration and Monte Carlo sampling, I don't know, whatever, okay? And then Markov chain, Monte Carlo. There's all sorts of stuff. We come up with all these names. All it just means is the math is too hard, and we're going to use the computer to try to help us answer it, okay? That's what it all boils down to. I'm not doing a good job selling the class, but I think we'll have some good examples or fun examples, and we could see kind of the applications of this, okay? In the beginning, we're going to have to learn about like random numbers, okay? This is something we take for granted with our computer, and I think it's fine. It's like almost like the problem has been solved, kind of. So, but we'll talk about, we'll start a discussion about random numbers and pseudo-random numbers. Okay, so on your computer in R, you can get random uniform numbers by running runif, right? For uniform random numbers. All right, and we'll have a brief talk about runif, okay? It's actually really complicated how it works. So I don't even understand how it works, so I won't be able to explain the full workings of runif, except we know that it works. Okay, it's the Mersenne, I don't know how, does anybody know how to pronounce this word? Mersenne, okay. These days we use the Mersenne twister to generate random uniform numbers. It's kind of a complex topic, but we'll just talk about that. Okay, and then once we establish that, then can we generate random numbers from other distributions? So we have things like R norm. What else do we have? Like R binom, any distribution, that, et cetera, okay? So from other regular old distributions, okay? And then Then we might want to talk about generating random numbers from more complicated distributions, okay? And this will probably specifically be like posterior distributions from a Bayesian problem. Okay, so this is kind of where we're headed, and I think we'll have some fun along the way. Some of it, you know, naturally there's going to be some dense parts that we have to get through and slog through in the math, but I hope to have fun, and I look forward to a good quarter with you guys, and I look forward to seeing you guys graduate and all of that. So welcome back to school, everybody, and we'll see you guys on Wednesday.